we can also have quarter wave plate. Quarter wave plate. A quarter wave plate means gamma is gamma is equal to half pi. 简单一点，我们就直接是 half pi。Gamma is equal to half pi. So when gamma is equal to half pi, W is equal to, we still use this orientation, pi over 4, or 45 degrees. The s-axis with respect to the x-axis, the angle between them is 45 degrees. So W now becomes this. Exponential minus I pi over 4. Exponential I pi over 4 times this is the W matrix, and this is cosine pi over 4 minus I sine pi over 4 minus I sine pi over 4 cosine pi over 4. Okay? So the result is the result is this 1 minus I 1, and I use this W matrix to time the input vector to get the output vector. This is 1 minus I 1 times 0, 1. Okay, so this is minus I 1, and we can factor out this minus I to get 1 I. Okay, so this is the left-handed circuit equivalence light. Okay, so a quarter wave plate change the relative phase between these two components. Okay, So originally we have ES plus EF times 1 over square root 2. And finally we have this ES plus IEF this is left-hand circularly polarized light. Okay? Quarter wave means half wave give this here a minus sign, and the quarter wave plate give this I factor. 好，就变成了一个 I 的 factor。好，不过这边要小心的就是，这个究竟是正 I 还是负 I， 还是要稍微小心啊，去了解一下啊。你从这里来看的话是，这个是 W0 W0 is equal to exponential minus I pi over 4 times 1, 0, 0 exponential I pi over 2. Okay, and I pi over 2 exponential I pi over 2 is just the I. Okay, so this means that if we use the crystal axis, then we change the phase of the second component from 1 to I. Okay, so we get this left hand circularly polarized light. 所以这个还蛮容易了解。So now we want to consider the combination of wave plate and polarizers.好，我们现在来把这两个结合起来。So now we consider the combination of wave plate and polarizer. Section 5.2 called intensity transmission. Intensity transmission. So this means that we can combine wave plate and the polarizer to find the final transmission intensity. Okay, we already know that for a wave plate, a wave plate can only change the polarization state of the light without altering its strength. But a polarizer can filter out some component of the final polarization. Okay, so which means that it can change the intensity of the light. So we combine these two components. Then we can discuss what is the final transmission rate. So suppose we have originally we have E vector written as EX, EY. So originally we have the intensity. Intensity is equal to the absolute square of this E vector. And this can be written as E dagger times E. E dagger times E is equal to EX absolute square plus EY absolute square, okay? And after penetration through the whole structure of the whole devices, the final E vector becomes EX prime, EY prime. Then the final intensity becomes the absolute square of the E prime vector, which is equal to E prime dagger times E prime, and is equal to EF prime absolute square plus EY prime absolute square. Okay? Then we can define the transmission or transmissivity or transmittance in the text.